Okay, I'm Blake Hannaford, and I'm going to show you how to get started with our symbolic inverse kinematics package, IKBT. So we're going to start by going to GitHub, and we're going to go into the GitHub search box and type search for IKBT, and the correct link is this one, the Biorobotics Lab IKBT. And we're going to clone or download, and this is the URL, so you hit this icon and it's copied to your clipboard. And then we go to a terminal, and I've got an empty directory with nothing in it, and I'm going to type git clone and then paste in the URL from my clipboard. So that was really fast. It's all set up. Now if I look, there is a directory called IKBT, so we're going to change into it, and we have a bunch of files and so forth. The one that really matters right now is the IK solver. That's the one we're going to use to solve this robot, and I'm going to pause for a second. So this is a very simple robot. It's just a 3-axis wrist are centered in the middle of the wrist, and it's sort of a classic example. Craig has it, and so it has 3 angles, capital A, capital B, capital C, and it can reach any rotation, and its forward kinematics are given by this, and so we're going to equate that to a rotation and solve it. So that's predefined in our package, and I'll show you in another video how to define new robots. But to solve that, we'll go Python, IKSolver, and wrist, which is a predefined robot. So it's computing forward kinematics and inverse kinematics based off of the DH parameters. I will pause while it does this. This will only take about a minute, but I'll pause. Okay, our output is done. There's a bunch of crufty ASCII output here, but you don't have to worry about that. We're going to get a concise report through the LaTeX package. So we're going to CD into the LaTeX subdirectory of our project. And in there are some files. The one that matters is this IK report template, which is a generic outline, and it incorporates the details from the wrist solution, which are in this file. So we just have to apply LaTeX to that. PDF LaTeX, IK report template, and we do that twice generally to resolve links, and then we take a look at it. So here is our big report. I'll go to the beginning. And so this shows that it's fresh. We just are doing it today. And then there's just some generic boilerplate here. For our robot, these are the DH parameters in equation 1 that we input. Again, another video will show how to do that. This is the forward kinematics. Then it solved it in this solution order. It's not necessarily alphabetical order. And here are the solutions. The initial solution for angle A has 2 solutions. AS1 means A solution 1 and A solution 2. And then for B, there's 1 solution to the equation, but we have to plug in both of the A's in here, so 2 solutions result, and the same thing happens for angle C. So that's the solution. It's correct. There's a graph illustrating the dependencies of those solutions. Right now we only have it in text form output. And finally, these are your solution sets. So the solution sets mean that a valid solution consists of these 3 joint angles, and another valid solution is these 3 joint angles, as opposed to some other permutation. This is obviously more complex with a more complex robot. And then for reference which equations are used to solve those angles. So that's your LaTeX report. Coming back up, we can also look at the code generation. Taking Python, for example, we have a file called IKEquationsRist.py, which has the equations which generates Python code. So we'll take a look at that. Came on the wrong screen. So this is Python code that implements and even tests that solution set. So that's our introduction to using IKBT. I wish you luck with your problems.